What's up, everybody? Welcome back to another weekly live stream from the Scalar Learning Channel, where we tackle SAT, Khan Academy problems, math problems, live every Wednesday. All right, let's jump into it today. Today we're working on data inference problems. Let me do a quick sound check over here. Make sure everything is coming through. All right, we're doing good. Let's do it. As always, I'm seeing these problems for the first time, which is part of the fun. And let me know if you have any questions. Feel free to put those questions in the comments section. Like this video if you find it helpful. And last but not least, subscribe if you want to see more SAT prep material on a weekly basis for the math. Here we go. Question 1. An archaeologist uses an accelerator mass spectrometer to find the age of a buried branch. At the 68% confidence level, the spectrometer estimates that the branch was 10,000 years old with a margin of error 200 years. Which of the following could the spectrometer estimate as the age of the branch at the 95% confidence level? Okay, so we've got, this is basically, let's see, branch was 10,000 years old with a margin of error of 200 years. Let's see. I think this is referring to standard deviation. I've actually never seen a question like this before. Let's see. So here's how I'm going to reason through this. I'm going to assume that if we increase the margin of error, the confidence level increases. My recollection, so this is actually interesting because I didn't know even they would test on something like this. I haven't seen anything like this before. But if I remember correctly, there's a rule in terms of standard deviation. So it's like right now, if we have a 200 standard deviation, right, this can go from 10,200 to 9,800, right? So if we, one standard deviation away, we capture 68% is something like that. And then I believe if we go to 2 standard deviations away, this is my recollection again, then we capture 95% of the data. So this is my guesstimate that it's going to be the same, it's going to go on the same value, but when the margin of error is going to increase, meaning we're allowing for an additional standard deviation in each direction. So it's like now we're going all the way up to 10,400 and 9,600. Man, I did not know that they would give this type of a question. So I think this is the right answer. I think it's B. Let's see if I'm right here. Okay, it's correct. Let's read the reasoning because I want to see if that's exactly right. Okay, so you don't actually have to know that rule about standard deviation and capturing 95% of the data. It just wants you to reason through and say, well, okay, it's a wider margin of error, so it's a greater confidence level. Okay, that's fair, because I thought that would otherwise require a more knowledge than I thought you needed for this test. Next, a random sample of 500 residents of a town included 173 residents who primarily spoke a language other than English at home, with a margin of error of, okay, 73 residents who spoke English or spoke a language other than English at home, with a margin of error of 25 residents. 25 either way. Okay. A confidence level of 98%. If the town has 25,000 residents, how many residents primarily speak a language other than English at home with a 98% confidence level? This is actually less of a data inference question. This is more of a ratio question. Let me show you what I'm talking about. So we have 173 out of 500. We already know this gives us our 98% confidence level. And now they want out of 25,000, what's going to be that equivalent value. And that's it. It's a proportion problem, and now we can just cross multiply. This is a calculator question, so I'm going to use that calculator. 500x equals 173 times 25,000. 4325. 4325000, and then we divide both sides by 500. Divide both sides by 500, and we've got 1, 2, and then 4, 3, 250. Okay, I can do this in my head. It's 86,500. Because it's like dividing by 10, but then I'm dividing by 5, so then you double it. So it should be 86,005. Oh, sorry. I must not have canceled out. Yeah, no extra zero, excuse me. 8,650. And then, oh yeah, and then they have that 25 margin of error, so it's this. Because we go down by 25, that gives us the 8,625. Up by 25, 8,675. So that incorporates the margin of error. So this should be right. Oh. What happened? Oh no! I forgot to scale up the margin of error. Shoot. Alright, so what I missed was that 25 residence. You have to scale that up too. Total mistake. So the 25, right? You could say a margin of error. The way we do that is 25 out of 500 equals. So it's a two-step problem. Totally threw me off there. Over x over 25,000. Okay. And then we cross multiply. I mean, you can kind of see this is 550. We have to multiply this by 50. But anyways, if you cross multiply 500x equals 25 times 25,000. 625,000. And then we divide it by 500. Right. 625,000 divided by 500 equals 1250. So the new margin of error is 1250, not 25, and then we got to add that to this, and we get 9,900, and then when we subtract it, we get 7,400, and that's the new range, which is why A is correct. Okay, these are tricky and new from what I've seen, so that's cool. All right, in the National Health Nutrition Examination Survey, 80.5% of the participants had healthy levels of high-density lipoprotein HDL cholesterol. The estimate has a margin of error of 1.5%, a confidence level of 95%. The participants were a random sample of United States residents. If the U.S. population at the time of the study was 316 million, what is the estimate at the same confidence level of a number of people in the U.S. who had healthy levels of HDL cholesterol? All right, so here we go. 80.5, blah, blah, blah. Okay, all we got to do is take 80.5% of 316. This is a calculator problem, so that means we do 316 million. But it's in millions, so we can just say 316. And we need to take 80% of that, or 80.5%, which is 0.085 times this. So 316 times 0.805 equals 254. All right. So we'll just approximate 254 million. But then we need to factor in this margin of error, so that's not going to get me 2 times in a row. Now I have to multiply 0.015 times 316 to get that range. 0.015 times 316 equals 4.74. So we'll round up to 5, I guess. So 5 million. So it should be 259 down to 239. So this should be the range, assuming they've done a little rounding. Uh-oh. This is the closest one. I don't like that, because I would have rounded this up to 5, but I think they rounded the final answer, is what it must have been. And they left it at 4.74. They probably left this at 254 point whatever. So I think it's probably this one. Yeah, this doesn't make sense. This goes way too low, so it's got to be this. All right, cool. Nice. Next. After randomly sampling 1,000 cars, a car wash determined with 95% confidence that the mean time needed to wash a car is 8 minutes. and 56 seconds with a margin of error of 7 seconds. Which of the following could be the bounds of a 90% confidence interval based on the same sample? So again, 90% confidence. Now we're tightening that margin of error range. We're trying to make a closer prediction. As we widen that margin of error, we can be more confident that we're probably in the ballpark. So if we have, we're still going to say 8 minutes and 56 seconds, right? Is our starting point. We got a margin of error of 7 seconds initially. So maybe, I don't know, let's drop it to 5 seconds or something like that. Yeah, maybe even 4 seconds. So I'm just giving you a ballpark idea. Then we'd have a range of 9 minutes. I'm just picking easy numbers. And 8 minutes and 52 seconds. Something like this. So let's see. Let's see if this one makes sense. So here we go. 8 minutes and 50 seconds to 9 minutes. However, now they're going up by 4 and down by 3. So that's still a margin of error of, down by 6. That's not a precise center on the same 8:56. That doesn't make sense. So 8 minutes and 40 seconds. So now they're dropping by 14. And then they're adding 14. See, these aren't centered on the day on 8 minutes 56 seconds. Like, it should be equally up and equally down. 8 minutes and 40 seconds. This drops by 16 and adds only 4 seconds. This drops by 6 and then adds 4 and 9. So none of them actually are exactly centered. 95%. So that margin of error, see, what I was expecting was, okay, because originally this would give us 903, right? I'm adding 7 and then I'm subtracting 7 and we get 849. Okay, so we're looking for something broader than this. This still comes up higher. This comes up a little higher, but I don't know. I don't like that. This goes below that. This doesn't go above the 903, right? Oh, sorry. We need tighter. Excuse me. I'm saying it backwards. We need it to be tighter, not. No. We do need it to be wider. Sorry. All right. So then we've got 8 minutes and 40 seconds. So this goes beyond. It doesn't go beyond symmetrically, but this is our best answer so far. This still stays above. This gets tighter. So we want a. Right? So if we got tighter, no, I'm getting so mixed up. I'm so sorry. We do want it to get tighter. Excuse me. So we want the range to get smaller because the confidence level is going down. So the margin of error, yeah, that's right. So what I first said, we need this to get into a tighter zone. So this actually gets wider, so the confidence level should be going up. This one gets tighter, right? It drops by 3 seconds, goes up by 1 second. This one goes down and up. This one goes... Yeah, so I'm going to say it's this guy. All right. Wow. I really got mixed up for a second. But I hope that makes sense. Look, the bottom line is the confidence level gets lower. That means the margin of error is going to shrink. If the margin of error expands, the confidence level increases. So there you go. All right. Last but not least here. Okay. An archaeologist uses an accelerator mass. Oh, wait a minute. This is the exact same problem at the beginning. All right. I think this was the answer. That happens every now and then. So it says, which of the following could estimate? I think this is the same idea, right? 95% confidence level. We have the same starting point. We increase the margin of error. Let's go back to question 1 if you want that full explanation. All right, cool. 4 out of 5. That is it for the weekly Wednesday live stream covering math questions from Khan Academy in their SAT section. If you have any questions on what I covered, please leave the question in the comments section. If you like this video, please click like. And if you want to see more, subscribe to the channel. Much appreciated. If you could show me some love there. And I hope you guys have an awesome rest of your day, and I'll see you guys next time. Take it easy.